For our third example and third exercise for the SolidWorks motion tutorial, so we will be discussing about the roller on a ramp. So in this exercise, we'll add contact between the two bodies and experiment with friction between the bodies. So what are those bodies? This is the ramp and the roller. Okay, so first is you have to model the ramp. So this is the open a new part, then model this in the front plane, and as shown, do a triangle of 7 in height and 30 degrees. Then extrude it and model this in another, and you will be arriving to this model ramp. Then open a new part, then make a circle and extrude. Use a material of PVC rigid to be same with the model. Then do a cutout at the front face of the cylinder to make a wheel or a roller. Then make it red, or if another different color doesn't matter, and save it with the name roller. Okay, after making those two parts, we'll open a new assembly, insert the ramp first, and place it at the origin of assembly, insert the roller. So from here, we'll start. Okay, so I will open SolidWorks. So let's open first the ramp. Okay, so this is the ramp. So I will make an assembly from the part. So first, what will be your fix will be always the first. Then insert, so do the shortcut. I will look for the roller. Alright, so I have the roller and the ramp. So let's meet it first. So as discussed, from this one, we should set up the correct height of the roller onto the ramp. So first is we need to make a temporary axis to the roller. So use tools. So we select the sketch tools. So there will be no axis. So what will happen is from the heads up view toolbar, select view and temporary axis. So let's save this first. Save all. Ramper. That's for my name. View. Then display. Modify. Where can you find it? So look for the temporary axis. So does it have the workspace, user interface, touch mode, lights, camera, action, modify, hide, and show. So there you go. Temporary axis. So when you click the temporary axis, a blue imaginary line will appear. So next, so add a distance between the roller and the axis bottom, which is about set to 6.5 inches. Okay, so mate, click the axis. So let's reference from the axis about 6.5. So that is 6.5. So alright, then mate, the roller should be touching the ramp tangent. Then we will do advanced meet to make it evenly this position. The roller is in the middle. So first is we'll make advanced meet of using the width. Select the ramp. So now it's aligned. Notice it's already locked in. It's just rotating on its position. Then let's check if we have the same distance. Voila, 6 inches. So our setup is good. Alright. Now turn off the temporary axis. So view, hide and show, temporary axis. Then actually we will have it. The mating should be the distance. So press, but don't ever touch the mating, the part prior simulation. Now go to the motion study, click the motion analysis. Now we will start with our simulation. So since we are simulating two parts that will be touching each other, we'll tell the SolidWorks motion use contact. So we will simulate two bodies, so the roller and the ramp. So by using the contact command, you are telling SolidWorks that this should not be uh, going in, this roller should be having some contact with the ramp. So we have this default categories, the material, the friction coefficient, static friction, then the elastic properties, impact or restitution coefficient. Restitution coefficient is something that it absorb the impact. It's like a foam or a rubber. And the material will be, you could select this default material, acrylic, aluminum, nylon, rubber, steel. So if you don't have any detail, leave it as default, or you could uncheck this. You're not particular on the material. Then friction, if you want to indicate the friction, so you could alter that value. Okay. If you uncheck the material, you will be able to edit the friction. Alright. Once you have the value, let's go what is the next simulation. So we will add the friction later. So but our initial simulation will be easier to verify with the friction. So as per the module, we should edit the solid body contact and check material and the friction. So when we uncheck this, set the frame rate to 500 and check the backslide. Use precise contact. So let's go change the frame rate to 500 and use precise contact for since we are dealing with contact analysis. So calculate. So as the time indicated, so change the duration to 0.5 seconds. So zoom in. So let's do zoom in. So we will be simulating using 0.5 seconds. So I just do as mandatory saving, then calculate. So what if we do calculate and nothing happen? Why? Why nothing happen? Because we don't use what we don't use. We don't use gravity. Okay? Okay, so we don't use gravity for this simulation. This one. So I just do it for you to check and appreciate. So it will not fall because we don't put gravity. So let's add gravity. Should be pointing downward. Now click calculate. Notice the roller already drops. Alright. So I was able to escalate or highlight that it will not drop because there's no gravity. But if we put a gravity, then we'll be able to see the roller slide down. So let's create a plot of magnitude of the linear velocity of the roller versus the time. So let's put the plot, displacement, linear velocity, the magnitude overall, and the linear velocity is about 65 inch per second at 0.35 seconds. So do we have the value? Oh, this one is about 68 inch per second. These values agree with those calculated at the end of this document. Translational velocity. So let's do another. So we don't have to put this one. So I was able to get 68 inch per second. Okay. Now check the friction box and set the coefficient of friction to 0.25. What will happen to the roller? Will it rotate? So let's see. So what's the value indicated? 0. The mu is 0.25. Then calculate. What happened? Does it rotate? So based on this model, our simulation did not rotate. So let's go back to the simulation and let's correct the model. Still, it is just sliding. So should start to rotate. Okay. So to continue, the friction will be, the mu will be about 0.25. So make sure that your model, that the tangent is also suppressed. So when we calculate this, the wheel will now rotate and we'll move further up to the ramp. So as you can see, if we will find what will be the velocity at the time it hits the ramp, so it's about 53 inch per second or about 54 inch per second. So looking at the PDF, it's about 54 inch per second. So now we will add the trace path to click on the point near the outer rim of the roller. So to see if the wheel is already rotating, so let's put a trace path. So let's select vertex. As you can see, when we make it move, when we calculate this one, you can see the wheel is already rotating. Then without the friction, just make it to be highlighted. I will uncheck this, then calculate. Notice that the trace path will also see a sliding motion, which is true, right? Without friction, you will not make the wheel rotate. Alright, so I will just be activating again and calculate. Alright, now we're able to see the difference between without friction. Now change the friction coefficient to 0.15. So we should be seeing that the trace path will be smoother. So let's see if we will be able to see this. From 0.25, let's use 0.15, then calculate. Alright, so as expected, we are able to see a smoother curve. So in the attachment, it is shown that the coefficient of friction requires to prevent slipping is about 0.21. So does it slips? So let's check. So I want to see a slower version. So as per the PDF, we should be getting about 0.21 only to avoid slipping. So let's change it to 0.21. Alright. So that's is our example for the roller on the ramp. So let's just add some flavor for this. Okay, uncheck this and use the material. So let's use the default material acrylic. I'm not using the friction. So let's calculate. Oh, if you use acrylic, it will just slip. Now let's use aluminum steel dry and aluminum dry. Calculate. So it's just slip again. Okay. So let's use aluminum greasy. rubber greasy. So what will you expect? Slightly, the wheel is not still rolling. Why? Because we did not activate the friction. So if we activate the friction, you can see the mu is 0.03. We altered the material, the mu is adjusting by itself. Okay, see? So if we use aluminum greasy, aluminum dry, then calculate, you can see we are slipping. But if we will use the value or the condition that is not greasy, so since the mu is only 0.03 and use the rubber dry, so what we'll expect? We expect that it will now rotate. Okay, that's for my example for the roller on a ramp. Thank you.